Let's start with this polynomial x to the fourth minus x minus 1. And let's say we want to know, does it have any roots? Is it ever equal to 0? We could try to factor it, but this is a fourth degree polynomial, and I don't know how to factor that. So let's try something else. Since it's a polynomial, it's continuous everywhere. So if we call this function f of x, we can try to use the intermediate value theorem. To remind you, here's the statement of the intermediate value theorem. If f is continuous on the closed interval a to b, and m is some value in between f of a and f of b, then there's at least one point c between a and b such that f of c equals m. And this conclusion of the theorem, that's exactly what we want. We want to know if there is some point such that f of c equals 0 in our case. So we're going to be using 0 for m. And we already know that f is continuous, so all that remains is we need to find f of a and f of b such that m, which is 0, is in between f of a and f of b. So let's just plug in some stuff, and I'm going to graph it so that we have a good picture. We can start with f of 1, and that's going to equal minus 1, and that's down here. And we could try f of 3, and that's 81 minus 3 minus 1 is 77, so that's way up here. And then 0, the x-axis, is in between where f of 1 is and where f of 3 is. And therefore, by the intermediate value theorem, there is at least one place where the graph of f will intersect this x-axis. So we definitely have at least one root. Now, we don't know where this root is exactly. The intermediate value theorem only tells us that it's somewhere between x equals 1 and x equals 3. If we want to narrow it down, we could try plugging in something like x equals 2. If we take f of 2, that's 16 minus 2 minus 1, that's 13. So that's up here. And applying the intermediate value theorem again, that means that for sure we'll have at least one root between x equals 1 and x equals 2. If you wanted to pin down the location of a root even further, you could just repeat the process. You could plug in x equals 1.5, for instance, and just keep going. However, this is a pretty slow process. If you want to get things precise, you'll learn faster techniques like Newton's method a little later in the course. But if all you care about is there a root somewhere, then we already have our answer. The answer is yes, there's at least one root between x equals 1 and x equals 2. Whether there are roots elsewhere, like maybe between 2 and 3, we don't know. But there definitely is at least one between x equals 1 and x equals 2. So that's basically how you use the intermediate value theorem. It's really exploiting the continuity of your function. Presuming your function is continuous to begin with, you should always be sure to check. Anyhow, we have some problems for you to play around with it.